Imagine pausing for a moment and questioning the most fundamental certainty in your life, that you are real, and that the universe you inhabit is tangible and out there, governed by laws discovered and refined over centuries. Most of us stroll through existence never doubting this basic premise. The cosmos, we're told, burst forth in the violence and brilliance of the Big Bang nearly 14 billion years ago, forging stars, galaxies, planets, and, eventually, beings conscious enough to ask where they come from. But what if everything you know about yourself, about the world, even about the history of the cosmos, was a mere illusion? What if reality as you perceive it isn't reality at all, but the fleeting imagination of a universe long since dead? The waking dream of physics on the grandest scale? This unsettling notion may sound more suited to a late-night philosophy debate than to sober scientific discussion. But surprisingly, it emerges from some of the most profound insights modern science offers. To understand why, we need to examine three key concepts. Ideas that together force us to re-examine our place in the cosmos. First is the curious nature of time itself, and what physicists call the arrow of time. In everyday life, it's obvious. A dropped glass shatters, tree leaves fall, water ripples outward from a stone with rings ever expanding, not collapsing. Pour a drop of ink into a clear glass of water and watch as it spreads, coloring the water but never reassembling into a neat red sphere. We all experience time flowing forward, past turning into present and present into future, with certain events never happening in reverse. Yet, on the level of molecules and atoms, the rules are not so strict. The tiny particles making up water and ink follow the same laws going forward as backward. If you could track each molecule's path, you'd find nothing that strictly distinguishes moving forward from reversing their motions exactly. So why can we never unscramble an egg? Why does a mess, once made, almost never spontaneously clean itself up? Here, it's not the underlying fundamental laws that dictate the direction of time, but sheer probability. The number of ways things can go from ordered to disordered far exceeds the alternatives. It's not impossible for the molecules of ink to regroup and separate from the water, but given the staggering number of ways they could be mixed, the odds against spontaneous separation are so immense that even the lifetime of the universe is nothing compared to the time you'd need to wait. Over unimaginable spans, if we were somehow able to watch, we might witness all sorts of bizarre events, maybe even a brain, spontaneously forming from chaos. With this in mind, let's turn to the second concept, the far future of our universe. Long ago, the universe burst into being, but it's far from static. Galaxies drift apart, dark energy stretches space-time ever wider, and the stars, one by one, exhaust their fuel. Fast forward to 100 trillion years in the future, and the last sun in the universe flickers out. Now, only the cinders of dead stars and cold, dim planets remain. But even matter itself is not eternal. Black holes slowly evaporate, and even the cosmic microwave background, a whisper of the Big Bang, is diluted by expansion. Eventually, only a vacuum remains, swelling ever outward, animated only by the faint hiss of particles emerging for the briefest moments before disappearing again. This is not the end, though, but a new kind of universe. One that resembles a glass of water with ink dissolved beyond retrieval, its molecules shuffling endlessly. Here, time has lost its original narrative, but it continues, and with it, the possibility, however remote, of fluctuations, of randomness organizing into temporary forms. Just as the laws of probability allowed, with nearly impossible odds, a blob of ink to reappear in water, so too can these particles generate anything, from planets and galaxies to fleeting bursts of complexity. And here comes the third and wildest idea. What if, given infinite time and endless shuffling of particles in an otherwise dead universe, every possible arrangement is not just possible but inevitable? Imagine a monkey typing random letters on a keyboard. Given enough time, the monkey will reproduce the works of Shakespeare, Eminem, or anyone else. Extend this logic to the cosmos. A random fluctuation could, in principle, assemble not only a planet or star, but something far simpler and statistically more likely. A conscious mind, complete with all the experiences, memories, and beliefs that you now possess. Suddenly, the picture darkens. Scientists have a term for this hypothetical apparition: the Boltzmann brain. You, sitting wherever you are, may not be a person grounded in a physical body, with a coherent past spanning years and decades. Instead, you could be a passing thought, a brief and lonely mind conjured by sheer chance in the distant darkness of a dying universe, complete with memories and perceptions, only to vanish again as quickly as you appeared. Compare for a moment the number of ordinary human brains, those emerging through natural processes, born to parents, living lives, leaving behind children and memories, with the number of Boltzmann brains that could flicker into existence over eternity. Given the odds and the vastness of time, the number of random, disembodied minds is not just larger, it is infinite, mathematical infinities dwarfing even the grandest sums imaginable. So which are you? A genuine embodied human being in a universe with a cosmic history, or a hallucination of physics, your memories as evanescent as the molecules reforming in a cosmic glass? Fortunately, even in the wildest thought experiment, the story does not end here. The very fact you ponder this question, using laws of physics deduced and tested and found reliable, means your knowledge matches a consistent reality. If you were truly a Boltzmann brain, the knowledge encoded in your brain would itself be random. The laws you discovered would be as likely to be gibberish as to make sense. The very reliability of your perceptions and the coherence of the scientific framework argue against the idea that you are a passing fluctuation. Still, sitting with this thought exercise teaches us something profound about our nature and our universe. Contemplating the edge of probability, the astonishingly improbable, reminds us of the limits and the strengths of scientific reasoning. It underscores the importance of seeking ever deeper, clearer understanding and not taking our existence for granted. In the end, while the specter of the Boltzmann brain drama may unsettle us, it also affirms our ability to ask questions, to probe, and to glimpse, however faintly, the ultimate nature of reality. We may not, after all, be merely dreams of a dead universe, but thinkers, observers, and explorers, living, breathing participants in a cosmos both stranger and more beautiful than we dare to imagine. Did you find our videos helpful? Please like and subscribe to our channel so we can be motivated to answer the questions that people are still wondering about.